Okay, so let's get into Oracle RAC Database Administration. And in this lesson, we will get into Enterprise Manager monitoring and management. I will more focus on management. And then we will get into a RAC database management. And then we will get into RAC instance management. And the last thing is session management. Because of the many discussions from this lesson, I will have to split this lesson into small pieces. So that way we're going to have a better discussion. Objectives here is, after completing this lesson, you should be able to use Enterprise Manager cluster database page. So I will briefly review Enterprise Manager cluster database page, cluster page, and meaning of each segment, each sections. And in lesson 8, we will have a chance to discuss performance information in Enterprise Manager more detail. And then we will get into Oracle database physical structure, especially in RAG environment. So we will have to discuss redo, undo, and local temporary table space concept. And then we will discuss about instance management. In RAG environment, there are more than one instances as an access point to Oracle database. So we will discuss how to manage instances in RAG environment. And then we will discuss session management at the end. In the very beginning, I added this information, separation of a duty for administering Oracle Real Application Cluster. And we have a sysRAC new administrative privilege. And this feature eliminates the needs to use powerful sysDBA administrative privileges, a privilege for Oracle RAC. In order to control RAG instances and in order to manage a RAG database, we used to log in as a sysDBA. If that is the case, sysDBA can do many things, including the viewing application data and also controlling RAG instances. So in order to lower and limit the privileges that admin can do, and starting with the 12.2, we use another new privilege, which is a subset of a sysDBA, which named the sysRAC. It is a default mode for connecting to Oracle database by the Oracle Clusterware agent on behalf of RAG utilities like SRVCTL. For example, you want to stop RAG database instance. Then you're going to run SRVCTL stop database command or stop instance command. Now to run this command, SRVCTL must connect to RAG instance. We used to log in as a sysDBA. But starting with the 12.2, we log in as a sysRAC. And no sysDBA connections to database are necessary for everyday administration of Oracle RAC database cluster. And at the end, we have the way to connect to Oracle database instance as a sysRAC. But this is not main goal of a sysRAC. The main goal of a sysRAC is the third bullet. SysRAC is default mode for connecting to the database by Clusterware agent on behalf of RAG utilities. Wait a minute. What is a Clusterware agent? Okay, so we had a discussion on this area. So let's take a look at this. You probably remember this architecture, Clusterware processes. And this was covered in lesson 1. When you look at this diagram here, and on top we have HA process. HA process, it starts CSS agent and CSS monitor, ORA agent, and ORA root agent, and ORA agent, app agent and script agent. Especially ORA root agent, it starts CRS daemon, and also another 2 agents. Now, especially in this case, ORA agent, and this agent process, it is responsible to start and stop RAC database instances. So when this agent connects to RAC instance to stop and start, and it log in as a sysRAC to RAC instance. Okay, so this Oracle clusterware agent is responsible to control RAC instances by connecting edge sysRAC. So let's come back. Okay, so let's get into Enterprise Manager portion. We can check one by one here. Enterprise Manager, it shows you cluster database information. So here we have ORCL database and its status. This database up and running. And if you want to actually manage instances, then you can click this button. So the left-hand side panel will be extended, and then you will see the list of instances. And according to a summary status page, and this is a 2-node RAC database, and this version is 12.1. And if you have 18C database, and it will show you your current database version. And total number of sessions in this example, 163. And also in the performance page, I love this page as a good starting point to monitor RAC database performance. Now when you get into performance page, under cluster database menu, and you will see activity, active session information, and also your database activity information. And when you look at here, you have actually a CPU and user I/O and wait. And CPU is a green color, and the rest of the items are wait event and wait time. So meaning that in this graph, you can categorize your database activity by CPU and database activity by wait time or wait event. For example, you may have this kind of a graph. I'm going to use green color, and you may have this much spike here, and also I have this much spike like this. So if this is your environment, how would you interpret this in a graph? In the bottom, this is in a CPU. So meaning that at this time, around 12, you have one average active session that is consuming CPU. And also, you have this number here. This is a little over 3, so I will make it 4, for example. So since we have one session that is actively consuming CPU, and then the total average active session is 4, so we will have to calculate difference and 3. So meaning that 3 sessions are waiting for completion of disk I/O. So that's how you can interpret, because it is a cumulative number. And since your database activity time is directly related to average active sessions, by analyzing average active sessions, you can easily understand your database activity, and your database activity can be analyzed by CPU and analyzed by wait event. And suppose that this spike is not user I/O area, but it's a wait area, for example, orange color. If that is the case, you will have to get into performance page to understand further. The reason why we made a user I/O and cluster as part of this the performance graph is because in the clustered environment, user I/O is the most common wait event, and cluster is also another common wait event in the clustered environment. All the other wait events are available in the performance page. In the performance tuning chapter, we will get into this area in more detail. And also, if your system is a CPU dominant system, for example, and then your system is currently running slower and slower, then you may want to take a look at top SQL statement as well. In this example, in the last 60 minutes and last hour, information is available in this page. And when you scroll down, and you will also see this information, instance section. When you look at instance section, I have an instance name, ORCL3. And its host name is host01. And the second instance name is ORCL1, host name is host02. You may have a question here. We expect ORCL1 on host01, ORCL2 in host02. How come we have actually the name mismatch here? ORCL3 is running out of host01, ORCL1 is running out of host02. It may be because your database is policy managed database. So, we will have to understand differences between admin managed database and policy managed database. When you create database using DBCA, you have an option. You can create database with admin managed database type, meaning that we as administrator, you will have to specify exact location where instance must be running. ORCL1, it must be running out of host01. ORCL2, it must be running out of host02. ORCL3, it must be running out of host03. You must specify where to start in each instance. Where to start each instance. That's admin control. Now later on, if you have a server replacement, for example, I have to replace this server with a new server. My new server name is host04, for example. When you replace the host with a new server, then ORCL3 cannot be running out of a newly added server because my instance must be running out of restricted server based on host name. But my newly added server host name is different. Then admin must change clusterware configuration information to start ORCL3 in the new server manually. Okay? And we also have a policy managed database. Policy managed database means we want to create database in the server pool. I don't care how many servers in the server pool. You may have 3 servers in the server pool, 2 servers in the server pool, 5 servers in the server pool. I don't care. As long as there are enough servers, I want to start my RAC database instances. So, I can start my RAC database instance across 3 servers, 3 node RAC database. Now, if a new server is added, then I can expand my RAC database up to 4 node RAC database. And if you get rid of 2 servers, then your database will be scaled down to 2 node RAC database. So it dynamically increase and decrease the size of a RAC database because the RAC database instance placement is based on policy-based, based on server pool. So, we can actually scale up and scale down dynamically without having any problem. Okay? So one thing what you have to do is, when you create policy manage the database, you will have to specify cardinality. What is maximum number of servers where my RAC instances can be started? That's what you have to specify. Other than that, the host name doesn't matter. So I can start ORCL 1 maybe here, ORCL 2 maybe here, ORCL 3 out of here. Okay? Instance and host name do not have to match, because based on policy, instance location will be controlled behind the scene. So that's what we have to know. Okay, so now we are looking at instance page. So instance name in this example, ORCL underscore 3. And instance page, it gives you a similar graphical information. However, it doesn't show you cluster information because it is a localized activity information. And also, it will give you host resource information. Okay? So in the server where instance is running, okay, which component is considered as a top CPU consumer? So it will give you this information. And also top activity information is available, memory usage, and underlying storage is also available from this information. And this is a cluster page. When you get into target menu, and you will see cluster submenu. And cluster is a group of servers. So I want to monitor the members of a cluster and also clusterware installed in each server. So I want to check status of a software and also status of a cluster. In this example, we have 3 members in the cluster. However, 1 is down. Okay? So you can quickly identify which server is not available. In this example, host 03. Okay? So in this case, you have to check whether this is a planned outage or unplanned. That's what you have to check. And we can also check in a cluster database, in this case ORCL. And also we have a status summary information is also available. And also if you want to see topology information, you can go to topology view and you move your mouse over component, and then it will show you selected component details. In this example, listener underscore scan 3 running on host03.example.com, this was selected. And you can also view alert information. From the instance manager, you will see all open instance. And it's not only for instance 1, the local instance information. So this message can be from all of members of a RAC database. It can be instance 1, instance 2, instance 3, or this alert may be from the cluster members as well. So you will see received alert, and you can also handle this information by working with the support team as well when needed. And we also have a metrics. And what is a metrics? Metric is a rate of changes. By default, RAC database collect cumulative statistics. And cumulative statistics is called performance statistics. It's in the memory. And it is copied over to disk as well. Since the cumulative statistics doesn't give you a rate of changes in the problem time period, we need a way to derive meaningful and important statistics information. So starting with the Oracle version 10, we were able to use metrics as a rate of changes. And there is a background process called MMOM process. MMOM process periodically derive delta statistics from cumulative statistics periodically. and we are able to use it for proactive database monitoring purpose. And also, since the metric statistics available, you are able to set warning and critical threshold based on your service level agreement. And then we can actually save warning and critical threshold. And from that point, Oracle Enterprise Manager periodically compare between metrics and your warning and critical threshold. And if your metrics exceed the service level agreement or threshold, and you will receive alert messages, and you can take action. That's a proactive monitoring purpose. And you can also create blackout as well. And blackout is useful in case in case you have a plan to maintain database server. For example, you are planning to maintain host 1. If that is the case, OMS try to communicate with OMA, Oracle Management Agent, that is installed in the server that is being maintained. But you are maintaining a server, maybe agent is not available, or agent is running, but it doesn't know actual status of other components because you are maintaining server. Then OMS will post the warning and error messages through Enterprise Manager. If this is a part of your maintenance, you are aware of this problem and maintenance, then you can create blackout to disable uploading operation. Okay, so in server 1, we are maintaining the component. So disable uploading process. By doing so, OMS doesn't have to post warning and critical messages until maintenance work is done. So we can create a blackout as well in RAC environment. And you can also use a standalone version of Enterprise Manager. A standalone version of Enterprise Manager is called Enterprise Manager Database Express. It's a subset of your Enterprise Manager Cloud Control. And it will give you monitoring capability, and it gives you resource availability, and database activities, and top SQL statement, configuration of your database. So very similar information is available through Enterprise Manager Database Express. If Enterprise Manager Cloud Control is not available in your environment, but you want to monitor your database proactively, then Enterprise Manager Database Express will be one good option. And throughout practice activities, we're going to use Enterprise Manager Database Express a lot, so you will get an idea of Enterprise Manager Database Express. So up to this point, I briefly introduced how to manage real application cluster and view information on a real application cluster using Enterprise Manager. That's the first section.